let's get started. 6.1. So we have fundamental trigonometric identities. So our objectives, we're going to simplify trigonometric expressions, verify trig identities, and then write algebraic expressions as a trigonometric expression. Okay, so this is stuff that we do a lot of times in calc. If you guys go on to calc, you'll see some of that stuff as well that pops up. Okay, a couple of warm-ups. So the first one is, what's the quotient identity for tangent? What would it be? It's actually on that board that I just covered. There it is. So for tangent, it would be what? Sine over cosine, right? So that'd be cotangent. And then for the even and odd stuff, if the angle's negative for sine, then what's that equal to?
Negative
Cosine?
Cosine x.
You got it. And then tangent?
Negative tangent x.
Yeah. If you remember, the reason why that's the case is because tangent has sine in it, right? So that's why the whole thing's negative. Okay, very good. So we have all of this written for us right here. And we're going to be using those. One way or another, we're going to be pulling that information. Let's jump into it. First example. Simplify the expression. So what do we do, right? Like what would be like good first steps? Well, first off, we know that secant and cotangent can be rewritten with some of these identities that I have listed over here, right? So secant is the same thing as 1 over cosine, right? So let's rewrite it. So this is the same thing as 1 over cosine squared of x times, and then cotangent, we know that's the same thing as what? Cosine over sine. So let's write that down. So this would be cosine squared of x sine squared of x. Do you see some things reducing?
Yes.
I think it's going to be these guys, huh? Okay, those guys will be reduced. They're gone. So now I'm going to have 1 over sine squared of x. But we can't rewrite that. What is 1 over sine squared of x?
Cosecant.
Cosecant squared of x. There we go. Questions? Let's try another one. You know what, let's do right next to it. Same instructions. I treat these like, to me, these are like puzzles. They really are. You know, using all this information, it's like your dictionary in a way, okay? Can you apply that to make this a little bit simpler? Okay, try to put it in one expression. So looking at it, I can put this over 1, and I want to combine that into one fraction, right? Which means I need a common denominator. So my common denominator would be sine of x, right? So what I'm going to do, this already has it, so this isn't going to change. This will just be cosine squared of x over sine of x. However, this guy, to get a common denominator, I'm going to multiply top and bottom by sine of x. Just like what you would do with normal numbers. So this will become sine squared of x. It's like x times x, okay? And then the bottom will have sine of x. Okay? Now let's combine them. So we get cosine squared of x plus sine squared of x over sine of x. Keep forgetting to put equal signs there, just to show that we are simplifying here. Cosine squared of x, sine squared of x. That one you're going to see quite frequently. Yeah, it equals 1. It's one of our Pythagorean theorem identities here. So we're going to swap that out for 1. Wrong color. And what is 1 over sine of x? Cosecant. Yep. Again, when I created those problems, I didn't realize that that happened. It happens. Okay, questions? So, approaching these problems, a couple things. First, if you see something like this where you can use a quotient identity, do that. Rewrite them, see if it simplifies. If you have fractions, you want to try and combine them into one fraction and then simplify using those properties. Okay? All right, let's try another one. Simplify, and then I'm going to put here, write the final form with no fractions. So this is already one fraction. So I don't have to combine anything, but now I got to simplify that one fraction.
Thing on top like equal squared x or something?
Nope. It's close, but not quite. So what do we do? Well, the top we can't simplify. It's actually, I don't know if you remember from algebra, it's difference of squares. Okay? If I had this, x squared minus y squared, that's the same thing as x minus y, x plus y, right? Okay? But it's just with trig. One's a perfect square. That obviously is a perfect square. It'd be secant times secant. So I'm going to rewrite the numerator as this. Okay? So this is going to be 1 minus secant of x, 1 plus secant of x. And now in the denominator, I'm going to do one more simplifying part. So that's the numerator. I'll put an arrow there so we know why I did that. Denominator, do you see how both terms have a sine of x in common? So I can factor that out. I'm going to factor out a sine of x out of both of these. Okay? So I get sine of x, 1 minus secant of x. Okay? So down here, I'll put a little note. We're going to factor out a sine of x. Do you see some things canceling? I think we do, huh? Those are gone. They're reduced. So let's see what I'm left with now. So I have 1 plus secant of x over sine of x.
Oh. Missed that.
Now, look at my instructions. We don't want fractions. Okay? Don't know why. There's a reason why we don't want fractions, because we're probably going to use it in something else. So how can I do this? Well, what is secant again? Secant's what? 1 over cosine. So let's use that property. Okay? So it'll be 1 plus 1 over cosine of x over sine of x. Okay? So looking at that, I want to combine the numerator into 1, and then maybe that can help me simplify it to where I don't have a fraction anymore. Okay, so that's what we're going to do. So looking at it, okay, simplifying the numerator, let's see, I'm going to put this off to the side so you can kind of see what's happening. I don't want to just skip to this step and then people get lost. So here's what I'm going to do. 1 plus 1 over cosine of x, I'm going to multiply it by 1 over sine of x. Okay? Now here's the deal. I'll put this above it. Originally, it's this. That's what that says, right? This divided by this. But when you do division, you change the multiplication, do 1 over that. So now I'm going to multiply these together. So 1 over sine of x multiplied with this guy and multiplied by 1. Okay? So I'm going to get 1 over sine of x plus, wait a minute. I didn't get rid of it. Uh-oh. I made an error on my notes. That doesn't get rid of it, huh? Huh. Well, that's not good. Okay, so go back to my original thought. Because that's just going to be 1 over cosine and sine of x. Yeah, that wouldn't work. Okay, so let's combine the numerator then. We'll do it this way. More than one way to crack an egg. So cosine of x over cosine of x plus 1 over cosine of x over sine of x.
Oh.
But I don't think that's gonna.
It's like
See, when I worked out this problem, I was like, yeah, this works.
Cosine x squared, maybe.
That's what happens when you make up your own problems. Sometimes they don't work the way you want. Yeah, because that's not going to eliminate it either. This might be one that what I created doesn't work to where you could do that. It might just be what I have there. So yeah, let me do 1 or 2 more steps. If it doesn't work out, then this example unfortunately can't be simplified with no fractions. So, oops. So let's give it a shot. Let's still work with it though. I'm up for a challenge. So the numerator, 1 plus cosine of x over cosine of x divided by sine of x. So, yeah, I don't think I can pull it off. I'm still gonna have a fraction either way. Oh, that bothers me. That really does bother me. Well, because if I split that up, it's still back to where I was originally. Man, that bums me out. Okay, so let's do this. Because it's not simplifying any further. So I do apologize for your notebook, I really do. Because like I said, in here, I put that sine over cosine of x, which is not true. So I messed up there. So let's just do this. That's as far as we're gonna go. Unfortunately. Yeah, that's as far as we can go. Because even if I continue down this pathway, I'm still gonna be left with a fraction, so there's no reason to go any further. My apologies. My bad. Gonna make myself a note. I gotta change that example. Okay, so that's just simplifying expressions. I kind of want to leave that board up there, so I'm going to work with just these 2 whiteboards, okay? I kind of want to just keep that off to the side as a reference. So now let's verify identities. It's going to be the same approach, but we're going to pick a side to work with. Here we go. Maybe if I can keep the mark in my hand. Verify identities. Okay. I'm going to give you a couple guidelines to work with it, and then we'll jump into examine. So the first thing is, okay, you want to work with one side of the equation. This is going to sound weird. That is usually more complicated. Usually with math, you want to do something that's not complicated. So this is kind of the reverse of it. Step 2, you want to look for opportunities to apply fundamental identities. Step 3, apply basic algebra techniques such as factoring, multiplying and combining terms, writing fractions with common denominators. And then I included this last part because this will come up. Multiply by a conjugate. It's been a long time since we heard that word before. Conjugate. Okay? So step 1, work with one side of the equation. That's usually more complicated. Step 2, look for opportunities to apply those fundamental identities. Step 3, apply basic algebra techniques such as factoring, combining terms, common denominator, multiply by a conjugate. And then the last one we can consider here is consider writing expressions in terms of sine and cosine. Okay? To wrap things up. Now, does this always work for every problem? Not necessarily, okay? It's just kind of the unfortunate nature of these problems. So this is just a good guideline, though, that works with the majority, okay? So here we go. Let's give it a shot. Okay. So the instructions is just verify the identity. Okay, step 1 says work with the side that's more complicated. Would that be the left-hand side or the right-hand side?
Left.
Left-hand side, right? So what I'm going to do is I'm going to simplify this. And when I'm done, it should come out to be cosine squared of x. Okay? That's the goal. So again, I could have started with the right-hand side, but there's nothing to simplify, right? I mean, I could do 1 minus sine squared of x, but that's not going to get to this point. So we're going to use the left-hand side, and I'm going to abbreviate that, LHS, okay? That way I know that's the side I'm working with. So before I multiply these two, I have something I can use here, right? So sine of negative x is the same thing as what? Negative sine of x, right?
Yeah.
So let's rewrite that. So this would be 1 plus sine of x, 1 minus sine of x. So I'll just put that in red. That's the thing that I took care of first. Now I'm going to multiply those together, just like two binomials. So we get 1 minus sine of x plus sine of x minus sine squared of x. I can see some things canceling. That'd be this middle stuff. Those are gone. Okay, so I'm left with 1 minus sine squared of x. And then that's an identity, right? Let's look on that first board. What's 1 minus sine squared of x equal to?
Cosine squared.
Isn't that what I wanted? This works. All right. So this is equal to the right-hand side.
What is that symbol?
Usually when you're dealing with proofs or anything like that, they usually put like a little box there just to indicate that that's the end.
Like a shaded box.
Yeah, little shaded box. You see it in proofs a lot. Okay. Questions? Let's do another one. Am I okay to erase that? Did you guys write down the steps? Okay. I'm down to 2 whiteboards now because I'm not erasing this. But that's okay. Try this one. Same instructions. Verify the identity. What side are we dealing with, left or right?
Left.
Yeah, definitely left, even though we probably don't want to. But it's not that complicated. What I would probably do first is make it into one fraction, right? That way it's easier to work with. Because at the end of the day, I gotta make it tangent squared. So let's combine it into one fraction. So we're gonna deal with the left-hand side. Okay. Now, to make it one fraction, I need a common denominator. So my common denominator is gonna be 1 plus sine of x and 1 minus sine of x. Okay, that's gonna be my common denominator for that guy. So for the top part, I'm gonna have to multiply this by what, 1 minus sine of x, top and bottom. And then over here, I'm gonna have to multiply top and bottom by 1 plus sine of x. Okay? So let me go ahead and show that here. So this will be sine of x, 1 minus sine of x over 1 plus sine of x, 1 minus sine of x. That's me multiplying the first fraction. Minus. I'll do the same thing over here, but just 1 plus sine of x. Okay. And I would advise you, like when you're working through these problems, you don't want to skip too many steps. Because if you do make a mistake, which as you saw, I did, it'd be kind of hard to figure out where you made the mistake if you do skip those. Okay, let's go ahead. Now, I'm going to do two things here. I'm going to make it one fraction, and I'm going to go ahead and multiply this to these two terms and this to these two terms. Okay, so that's what I'm going to do here. So for the first one, I get sine of x minus sine squared of x. Okay, and then there's a minus sign there, so I'm going to take the minus sign with this and bring it into both terms. So minus sine of x minus sine squared of x all over my common denominator, which was 1 plus sine of x, 1 minus sine of x. So just to, again, this negative, I took it with this value and brought it to both terms inside. This is looking pretty good. I can already see some terms canceling. So those guys are gone. Okay. So what do I have left? Let's take a look. So in the numerator, I have a negative sine squared of x and a negative sine squared of x. So there's two of them, right? So I'm going to put minus 2 sine squared of x. Now, the denominator, I'm going to go ahead and multiply this out and put it underneath here, okay? The reason why I'm thinking that is because, again, I'm trying to make it equal to this, and that's not going to help. So if I multiply this out, maybe some things could cancel, or maybe I can use an identity here. So multiplying it out, and since this is the same term, just the middle, the signs are just different, shortcut is just multiplying the outsides. So this just becomes 1 minus sine squared of x. But again, if you want to multiply it fully out and see that the terms cancel, do that. We're just about there, actually. What is 1 minus sine squared of x equal to?
Cosine squared.
So this becomes minus 2 sine squared of x over cosine squared of x. And sine squared over cosine squared is? Tangent. All right. So then this is equal to the right-hand side. And we're done. Okay. All right. Any questions? So far, so good. By the way, it is perfectly acceptable if you get halfway through it and you're like, you know what, this isn't getting me somewhere. Then try again, okay? It's perfectly fine to have something that doesn't quite work out at first. You're like, you know what, maybe I should go back and try this method instead. So don't feel bad if your first attempt wasn't the greatest, because that can happen. Okay, so let's try one with the conjugate. Same instructions. Verify the identity. Which side looks more complicated? Left or right? Honestly, in this case, it doesn't really matter. They're both something I can work with. We've been doing left-hand side. We're just going to continue doing the left-hand side. So this one doesn't quite matter, but again, we'll just choose that side there. Now, there's not much to simplify in that part. So what I'm thinking about is let's multiply by the conjugate. Okay, if you remember what the conjugate is, you take your denominator, change the sign, and multiply top and bottom by it. Okay, so let's give that a shot. So this will be cosine of x over 1 plus secant of x. So we're going to multiply by its conjugate and see what we get. Okay. And again, this could work, this could fail. This will work, by the way. I wanted to make sure this conjugate one works. Okay, so the numerator, if I multiply those together, I get cosine of x, okay, minus cosine of x secant of x. Okay. And then the denominator, I'm going to multiply those out as well. Again, same symbol or same binomial there, just the signs are different, so it'll be 1 minus secant squared of x. So I don't have to worry about multiplying all the terms out. Okay. Now, the top, this can reduce. So secant's what, 1 over cosine, right? And this is cosine. So wouldn't that be cosine over cosine, which is 1, right? Okay, so let me put that off to the side here. So this is cosine of x times 1 over cosine of x, which just becomes 1. Okay, so let's do that. So this would be cosine of x minus 1 on top. Okay. Now, on the bottom, I'm going to try something out here. Okay. So over here, one of my identities, I have that tangent square root of x plus 1 equals secant square root of x. So if I were to match that, which is what 1 minus, okay? If I brought this to the other side and moved this over here, so if I subtract this over, this is 1 minus secant square root of x equals negative tangent square root of x. Okay, so again, what I'm doing here with this identity is I'm moving this over to match what I have here, and moving this over, which makes it negative. So now what I can do is where I see this, I can replace it with a negative tangent square root of x. Now, why did I do that? Because look at what I'm trying to prove. It has a tangent square root of x. And it has some of this, so I can kind of like see ahead of time what I need to plan for here. So this would be negative tangent square root of x then. Okay, so in this spot here, I'm using, I'll put the identity next to it. Okay, so I'm using that identity to rewrite it. Now, the only difference between here and here is they're kind of like flipped in a way, right? Like this needs flipped, and cosine has to be negative, this can't be negative. So what I can do to finish this is I can take a negative 1 out of the top and bottom. So I get 1 minus cosine of x, if I take a negative 1 out. We have negative 1 tangent square root of x. And then we can see the negative 1s are going to reduce. So I get what I was looking for. So this is going to be equal to 1 minus cosine of x over tangent square root of x. We did it. Which equals the right-hand side. Okay. All right. Questions on that one there? Does that look good? It's a lot to like process, like what should you do next? So that's why I was, wanting you to rewrite these identities. That way you can have it on hand and you can see like, maybe I'll try this, or maybe I'll try that method. Okay, so this one, we're multiplying by the conjugate to see what we can do there. Okay, I have 2 more to go. I'm gonna do one with logs. I'm gonna throw some logarithms in here. And then I'll do one with a trig expression to wrap things up. So again, gotta keep that on standby. Let's go go back to logs. We haven't done those in a long time. Okay, so again, verify the identity. So let's do natural log of sine of x plus natural log of cosine of x equals natural log of cosine of x. Oh, sorry, it's cotangent, not cosine. There we go. Okay.
Absolute value.
Yep. Remember, those trig values can yield negatives, right?
Yeah.
And if you think about the domain of natural logs, we can't have negatives. So therefore,
Right.
we're trying to eliminate that issue. So that's why the absolute values are there. Okay, looks complicated. This is actually very easy. Who remembers, if we're adding logs, that's the same thing as what? Multiplying. Yep, multiplying the arguments. So I'm going to use that property. So I'm going to use the left-hand side, because again, that has the most stuff, it's the most complicated. So we're going to use that log property. So we natural log of sine of x times cotangent of x. Okay? Now, cotangent of x can be rewritten. We could swap that out for what?
Cosine of x over sine.
Yep, so let's do that. There we go. See some things canceling? See those sine of x is going to be gone, right? They're going to be reducing out of this. So I just get natural log of cosine of x, which, hey, that's what we wanted. So that does equal the right-hand side. See? Easy problem. Okay. So any questions on that? So you could have just some prior algebra stuff that gets snuck in there, but if you know what the properties of logs are, that isn't really that hard of a problem. Okay, last one. So it's going to be the last objective that we're going to tackle there. Okay. So here's what we're going to do. We're going to write square root of 225 minus x squared as a function of theta, where theta is between 0 and pi over 2, by making the substitution x equals 15 sine of theta. Okay, oops, just toss some papers at you. All right. Okay, so we're going to make a small little substitution. So anywhere I see an x, I'm going to put 15 sine of theta in its place. Okay, that's what it wants me to do. Now the reason why there's a restriction on the angle itself is because we know that we don't want the square roots to be negative there, and that kind of helps us with that. So, what's this look like? Let's put it right here. Okay, so again, swap the x out. Oops, got the squared part. Put 15 sine of theta in its place. Okay, so equals. So I'm going to simplify what's in here. So it's 225. And then minus, this will be 225. Well, I don't need that anymore. Don't need the parentheses. So minus 225 sine squared of theta. Okay. Now notice, I can take a 225 out of both terms. Okay, So let's do that next. So take a 225 out, 1 minus sine squared of theta. So isn't that identity? 1 minus sine squared of theta? What would that equal to?
Cosine squared?
Yep. So you have 225, and it's going to be multiplied by cosine squared of theta. Now, because there's multiplication here, I can split up the square roots. So I have square root of 225, square root of cosine squared of theta. So doing that both, we're going to get 15 cosine of theta. That's my final answer. Okay, so that's us taking a function, plugging in a trig substitution, and then simplifying it to see what we get. That's something you do quite a bit in calc, especially when it comes to integration and so forth. So that's just giving you a little bit of practice of seeing it and how you can